Hello and welcome to Pharma-info with Shubhashish. Now today the topic is there in front of you, right? That is synthesis of Carbachol, right? So straightway we all know about Carbachol, right? Carbachol is a drug which is given to treat glaucoma, right? Okay. Glaucoma. Okay. Now why this particular drug has been chosen to treat glaucoma? Because this particular drug possesses meiotic effect. So how this meiotic effect evolved? That means this particular drug acts on muscarinic receptor. Muscarinic receptor belongs to what? Cholinergic system. So as a whole, this is basically stimulating the muscarinic receptor. Stimulation of muscarinic receptor leads to meiosis, that is contraction of pupilla, right? The contraction leads to what? Decrease in IOT, that is intraocular tension or intraocular pressure, and which influences, or rather which enhances what? The proper drainage of what? Or which leads to proper drainage of what? Lacrimal fluid, so that the dryness will go off, and thus glaucoma can be treated, right? Okay, I should not say glaucoma is totally cured. At least we can stop the further aggravation of glaucoma, right, with this particular drug. So Carbachol is the drug primary choice in the treatment of glaucoma. Why is it so? That we have seen, right? Okay, now we'll not go in deep of this particular thing. So this is found to be one of the clinical or primary clinical indication of Carbachol, right? Okay, now let us just sketch the structure of Carbachol. How this can be sketched? We have to go through the name. Let us just find what are the chemical clues that lies within the name, right? So what are those? If we just split Carbachol, okay, and do some manipulation with these two fragments, carba. From carba we can just put met. This has become carbamate, and call INE, choline. So that means there may be a chance that carbamate merge with choline form Carbachol, right? Okay, so if we just try to figure it out chemically, how it goes. So this is carbamate, right? This is carbamate. To that we have to what? We have to add choline. So choline is O is here, CH2, then N trimethyl ammonium. So this is your Carbachol, right? Okay. Now let us deal with the IUPAC naming and all. So N plus, that means some halogen must be there, salt of something, right? Salt of anything, right? So X can be bromide, X can be bromine, X can be Cl, anything, right? Okay. So Carbachol, that is Carbachol chloride or Carbachol bromide, something like this. Now, so we are concerned about with this. We are very much concerned with this particular thing, rather this, right? It's a small thing. Now, so this is according to IUPAC, nitrogen with a charge can be called as, or should be termed as agenium. So this is your agenium. To that agenium, trimethyl is there, and the other half is in the form of what? Carbamoyl oxyethyl, right? So as a whole, if we just try to merge them all together, how it goes? So it is the one, this is the two, second position, two of what? Two of this agenium holding what? Carbamoyl oxy, then followed by ethyl. We are done with this half. Coming to this half, should be in bracket, that means trimethyl over, and then azenium halide, right? So likewise, this is 2, then carbamoyl oxy, then ethyl, then trimethyl, then azenium, and then halide. Okay, so let's see that how it goes, the structure, right? So first the structure is going to be something like this: H2N, C double bond O, then O, CH2N, methyl, and methyl, right? So this is the entire skeleton, right? Now I just wish to break the entire skeleton into possible fragments to generate what? The essential reagents with which carbachol can be, with which the building can be constructed, right? Okay. So what are the areas that are likely to be, or that are vulnerable towards the breaking? This is the first area, second area, and third area, right? So these are the possible zone or zones which can be broken down into pieces, right? But here, each and every piece is important to us. Why? Because each and every piece has to be molded in such a way so that we can get the individual reagents, individual essential reagents with which carbachol has been made, right? Okay, chalo. So let us deal with one after another. Amino, the possible modification that can be done to this particular amino is ammonia. We have got the first one, C double bond O, flanked with oxygen and nitrogen. So definitely the C double bond O, while being acted or while acting as a reagent, should have two electronegative atoms. Why? Because this oxygen and nitrogen initially definitely they were having what? Definitely they were having the hydrogen, and it is the hydrogen of these two essential fragments with which the electronegative atom which is there in carbonyl group interacted and finally leaving behind the carbonyl group, right? So how it goes? So that means C double bond O may become something like this. Okay, C double bond. This is found to be the feature of C double bond O, right? So C double bond O now is flanked with what? Two halogen. With this two halogen, one hydrogen of ammonia interacted, HCl left, and leaving behind what? H2 and C double bond O. So here also same thing. Both are found to be electronegative, right? So that means possible thing is that to this particular third fragment there should be a hydrogen here. So we have got alcohol, that is ethanol, right? So what about this? We need to connect the CH to the other terminal with this nitrogen, no? So for that very reason, what we can do, we can put one halogen here, electronegative atom. So with that we have just completed the third fragment, that is HO, CH2, CH2, then Cl. That means chloroethanol, right? 2-chloroethanol, okay. And the final one, only thing is that we need to remove the charge, because we have to see this particular thing as a separate entity, okay, not as a part which is associated with this particular carbachol, right? Because we are in the process of what? We are in the process of procuring the possible reagents with which carbachol can be made, right? So that means the positive has to be removed, leaving behind simply a neutral amine, right? So now we have got the third one, that is trimethyl amine, right? So these are the four essential reagents, okay, which are involved in making what? Which are involved in making carbachol. Now, let us just bring them one after another. Let us see that what are the different steps, okay, or how many steps that carbachol can take, okay. So let us see and in which step and what are the steps and in which step these reagents are coming, right? Okay. So first and foremost, let us just react. Let us bring the second as well as the third reagent, that is carbonyl chloride. It reacts with what? It reacts with chloroethanol. To be more precise, 2-chloroethanol. Please do write, the name of the starting materials. Okay? If you are unable to write the name of the intermediate, no problem at all. But you are not supposed to, skip this particular, step, right? So whatever starting material that you are going to write, please do write, okay? Because in order to decorate your answer sheet, okay, in a proper manner, this should be there, right? It's a suggestion, what you can say. You can take it in your way, right? Now, so what will happen? Definitely, what can be expected here? Cl and H, both of them should leave, right? Should leave, leaving behind what? Leaving behind Cl, C double bond O, then CH2, then CH2, then Cl. So we have got a derivative of formic acid or formate. So what is that? 2-chloroethyl chloroformate, right? So this is what? 2-chloroethyl chloroformate. Because it's the derivative of formic acid, no? Cl. Assume that no, there is no Cl. Hydrogen is there. So that means formic acid, formate. So that means haloformate. So chloroformate, like this, right? Chalo. Now, what next? The next is we need to complete this particular terminal. This one, right? For that, what we need? This particular terminal, we have to make it what? Carbamoyl, right? So that means ammonia is the one which has to be brought. So what this ammonia will do? It will furnish one of the hydrogen. This will, liberate. This will liberate the halogen. So what will happen finally? The H2N will get merged to this particular, to this first intermediate. This is found to be the first intermediate. Now with that we have got the second intermediate, right? Now we are at the verge of completion, right? So verge of completion, we are left with what? The terminal amination, right? So that means we are verged with the amination. That means alkyl amination. So for that, the reagent that we have procured and kept in our storage, trimethylamine, right? So what this trimethylamine will do? The trimethylamine reacts with this, and finally there is a formation of H2N, C double bond O, O, CH2, CH2, N plus CH3, CH3, CH3 and halogen. And with that we have got what? With that we have got this is azanium, 2 carbamoyl oxy, 2 carbamoyl oxy, ethyl, trimethyl, azanium halide. So with that we are done with carbachol. Hope you have understood the fact and file lies in the making of carbachol, right? If you really like my videos, please don't forget to press the like button, and please do share my videos, right? So that it will get circulated amongst students and all. And please put some comments, okay? Put some comments, and your comments are very much important for me to grow, right? In a sustainable manner, rather. Okay, thank you very much. Thank you for your patience and all, and wait for the next video to come. Thank you.